Hello friends, today we will discuss two very important concepts of number system. One is your negative remainder and other is your Chinese remainder theorem. It might take little time to understand these theorems, but believe me, once you have understood it, or you can say you have mastered it, it can be a very useful asset for you. These concepts can be used in a question based on long divisions, remainders questions, questions on LCM, and some questions, typical question of algebra. Now let's start with the overview of the session. In this session, we will cover the questions on negative remainder. After that, we will cover the concept of Chinese remainder theorem, and then some questions based on Chinese remainder theorem, or you can say the application of the Chinese remainder theorem. And in the last, we will do some practice questions and their answers. Now let's start with the concept of negative remainders. Students, here I would like to tell you one thing, that while explaining these theorems, I will not use any big mathematical jargons, or you can say big mathematical terms. Rather, I would like to use very small figures so that as a layman you can understand what is the actual meaning and where we can have a practical application in our questions. So please have a patience while going through the basic of these theorems. Now I will start with the negative remainders. What is the meaning of negative remainder, student? What is the meaning of negative remainder? I will take very small example. If I say 6 divided by 8, what is the remainder? Positive remainder is 6, because when you divide 6 by 8, the positive remainder will be, student, 6. But again, if I say, can I say 6 divided by 8? 6 is how much less than 8? Student, 6 is how much less than 8? It is minus 2. So minus 2 is the negative remainder when you will divide 6 by 8. Or if I write minus 2 divided by 8, what is the positive remainder? Then what you will do? You will minus 2 in this number, you will add the number with which you are dividing, minus 2 plus 8. So it will be plus 6. So plus 6 is the positive remainder. As already we have taken 6 divided by 8, it will be, remainder will be 6. Now again, if I ask you 5 divided by 9, what is the negative remainder? 5 is how much less than 9? Minus 4. And what is the positive remainder? 5 divided by 9, it will be 5, students. So if I say minus 4 divided by 9, so what will be positive remainder? 5. How? Minus 4 plus 9, it will be 5. Is it clear, students? Now we will take basic example so that you can justify. If I write 8 into 11 divided by 9. First of all, do by the method which we have done in the school. 11 into 8 is, because these are small number, we can multiply. 11 into 8 is 88. When divided by 9, 9 into 9 is 81. So remainder will be 7. This is the universal approach which we have already known to us. Now if I will do it by negative remainder, students, 8 into 11 divided by 9. So 8 is how much less than 9? It will be minus 1. 11, when you will divide it by 9, students, then it will give remainder 2. So now multiply. Minus 1 into 2 will be minus 2. Minus 1 into 2 will be minus 2. And minus 2 when divided by 9 will give positive remainder as a 7. Which I have already told you, minus 2 plus 9, it will be 7. I am taking small example. Then we will do these questions on big numbers also, students. First of all, you should understand what is the meaning. and believe me, it is very useful concept which you can use in long questions based on arithmetic progression, geometric progression, in data interpretation, big calculations. So now take another example, student. If I'll take 11 into 13 divided by 15. What is 11 into 13, students? As a maths point of view, 11 into 13 will be 143. When divided by 15, it will give 15, 9, 135. Remainder will be 8. This is again universal approach which we have done in school. Now do it by negative remainder, students. 11 into 13 when divided by 15, it will be minus 4. It will be minus 2. What is minus 4 into minus 2? It will be plus 8. So answer will be 8, which is already here. So I think that we have done the concept of negative remainders with very small examples which we can correlate. And now just do the questions based on it. Question number 1, students, find the remainder when 13 into 17 into 21 divided by 15. Now what you can do, students, 13 divided by 15, minus 2 is the negative remainder. 17 divided by 15, it will be 2. 17 by 15, remainder is 2. And when you will divide 21 by 15, remainder will be 6. So now 6 into 2 into 2 will be minus 2 into 2 into 6. It will be 6 into 2, 12, minus 24. When divided by 15, give as a remainder minus 9. Give as a remainder minus 9. So what will be positive remainder, students? Minus 9 divided by 15, it will be plus 6. That means minus 9 plus 15. Clear? But again, now I am doing it by another way also, students. Like 13 into 17 into 21 when divided by 15. Again same, minus 2 into 2 into 6. Now what here you can do, students, instead of multiplying whole number minus 2 into 2 into 6, why I am telling, because you will understand later on when the big numbers are there, you can again break it in a small numbers. Like I will take 6 into 2. What is 6 into 2? 12. And 12 when divided by 15, 12 when divided by 15 gives negative remainder minus 3. Can I write here remainder will be minus 3 when divided by 15? So what is minus 2 into minus 3? It will be plus 6. Minus 2 into minus 3 will be plus 6, which is the answer. I have not multiplied whole number, students, because when the number is big, again then it can take a lot of time. We can break the number into a smaller part. 6 into 2 is 12. 12 divided by 15 gives remainder minus 3. Minus 3 into minus 2 will be plus 6. Answer is same. I think that you have understood the concept of negative remainder. Now do another example, student. Find the remainder when 123 into 126 into 129 into 131 divided by 127. Again you can apply same concept, students. 123 divided by 127, it will be minus 4. 126 divided by 127, it will be minus 1. 129, remainder will be 2, and 131 divided by 127, remainder will be 4. Now multiply, because number 4 into 2 is 8, into 1 is minus 8, into minus 4 is minus 32. So when you multiply, it will be 32. Now 32 is less than 127. So when you will divide 32 by 127, remainder will be 32, which is the answer. So orally, students, as you have seen, we can do this question orally without writing. But for our understanding, initially we are writing it. But with practice, we can do a lot of questions based on it. I think that now this concept is clear. And now I will go to next question, next concept, that is concept on Chinese remainder theorem. Now student, I will take again mathematical examples to explain you the Chinese remainder theorem. What does it mean? I will take small example, students. If I ask you, students, 2, 3, 1, 9, 7 when divided by 24, what is the remainder? Especially this theorem can be applied in the question of remainders, big questions of remainders. Initially I am taking small example, then we can do the application of this theorem in a later on stages. But first of all, understand. Initially I will solve it by your school way, like 2, 3, 1, 9, 7 when divided by 24. 24 into 9 is 2, 1, 6. Again 11 minus 6 is 5. 2 minus 1 is 1. 9. Then 24 into 6 is 144. Remainder will be 9 minus 4 is 5. 5 minus 4 is 1. 15. And then 7. 24 into 6 is again 144. And remainder will be 13. This 13 is our answer. We have done it by a very basic method which we have learnt in the schools. Now in Chinese remainder theorem, students, what we have to take care of? We are dividing this by like 2, 3, 1, 9, 7. We are dividing it by 24. Dividing it by 24. We have to take care of the number with which we are dividing. Break that number into two parts, which should be co-prime. Which should be co-prime. Like, first of all, you should know what is the meaning of co-prime number, students. Co-prime. I think that you are aware of co-prime numbers. If you are not aware, then please you can write two numbers are said to be co-prime, students, when their HCF is 1. This is very important thing. When their highest common factor is 1, students. Two numbers said to be co-prime when their HCF is 1. Now, what is the co-prime factor of 24? If I write a factor of 24, 2 into 12, 4 into 6, are these co-prime? Students, are these co-prime? No, students. Because in both the cases, HCF is 2. In both the cases, HCF is 2. While for co-prime number, HCF should be 1. Clear? Now, can I say 24, 3 into 8? Yes, this 3 into 8 is 3 into 8 are co-prime numbers, because you can check their HCF is 1. And now we have a basic knowledge of divisibility. When you can say a number is divisible by 3, students, sum of digits should be divisible by 3. Sum of 3. Check of 3. Check of 3. Check of 3. Divisibility check of 3. Sum of digits should be divisible by 3. Now if we will divide, if we will check 2 plus 3 plus 1 plus 9 plus 7, it will be 2, 3, 5, 1, 6, 9, 15, 7, 22. 22 when divided by 3, remainder will be 1. Now we can say when we will divide this number by 24, the remainder will be 1. When we will divide this number by 3, the remainder will be 1. So can we say when we are dividing this number by 3, we are getting 1 as a remainder. Now what is check of 3? Divisibility check of 8, students. Divisibility check of 8. Last 3 digits should be divisible by 8. Last, you can check, last 3 digits should be divisible by 8. Last 3 digits should be divisible by 8. Now, what is last 3 digit of this number? 197. Now when you will divide 197 by 8, remainder will be 8 to 16, remainder is 3, 8 3, 8 4 32, remainder will be 5, 8 4 32, 8 4 32, remainder will be 5. Now dividing it by 3, remainder is 1, and when we are dividing it by 8, remainder will be 5. Now the question is converted into, we have to find a least number. When we are dividing it by 3, the remainder should be 1, and when we are dividing it by 8, remainder should be 5. Now I will continue to the next page. Can we find least number which when divided by 8 gives remainder 5? I am not going into the algebraic terms, students. If I'll explain this question by algebra or by mathematical expression, very difficult to understand. Now what we'll do, we will write a small number, like I will write 8. When we are dividing it by 8, the remainder is 5. Now we have to check the number when divided by 3. 5 divided by 3, remainder is 1. When we are dividing it by 3, remainder is 1. Now if we'll add 8 to this number, 5 plus 8 is 13. This number will give remainder of 5 when divided by 8. Is it clear? Because 13 divided by 8, remainder will be 13 divided by 8, remainder will be 5. And when you divide 13 by 3, remainder will be 1. So this number is the satisfying both the condition. When divided by 8, remainder is 5. When divided by 3, remainder is 1. So answer will be 13, students. Just take one more example. I am writing a big number, 71832497. When divided by 72, students, what should be the remainder? What should be the remainder? 72. What is co-prime factor 72, student? 8 into 9. What is check of 8? As we have already done, last 3 digits should be divisible by 8. So 497, when you will divide it by 8, last 3 digit, 8 6 48, 8 to 16, remainder will be 1. That means we have to find a number when divided by 8 gives remainder as a 1. And what is the check of 9, students? Like in a case of 3, sum of digit should be divisible by 3. So same is the case. Sum of the digit should be divisible by 9. So what is sum of digits, students? 7 plus 1 is 8, 8 16, 3 19, 2 21, 4 25, 9 34 plus 7 is 41. 41 when divided by 9, remainder will be 5. So now question is converted. We have to find a least number which when divided by 8 give remainder as a 1, and when divided by 9 as a 5. Students, here we are making a cycles, but believe me, in an exam, when you will get a question, you will find a question, typical question, then choices are given. In these choices we can see the number which when divided by 9 is giving remainder 5 and divided by 8 giving a remainder 1. But again here the choices are not given, so we have to find the remainder. So what we can do, we can write 9 by dividing by 9, we are getting remainder as a 5. Now if I add 9 to this number, 5 plus 9 is 14. 5 plus 9 is 14. So this number is giving remainder 5 when divided by 19, and we have to check remainder of 1 when divided by 8. 14 divided by 8, remainder is 6. Not satisfying both the condition. Again you will add plus 9, 24, 14 plus 9 is 23. Check by 8, remainder is 7. Then again you will add 9, 30, 23 plus 9 is 32. When we will divide it by 8, remainder will be 0. And when you will add 32 plus 9, it will be 41. This number is giving remainder of 1 when dividing by 8 and remainder of 5 when divided by 9. So answer will be 41. This 41 is the answer. If you want to check, you can check it by the method which we have learned in the school. 71832497 divided by 72. Surely students will get 41 as a remainder. I think that the concept is clear. We have to see. You can also write instead of 9, in most of students the point comes in a mind ki sir, if instead of writing 9, if we write 8, again you can write 8. By writing 8 you are getting remainder as a 1. What I will do, I will add 1 plus 8, because now I have to add 8. 1 plus 8, that is 9. 9 plus 8 is 17. Now this number is giving remainder 1 by dividing 8. But what we want a remainder of 5 when divided by 9. 17 plus 8 is 25. This will give remainder as a 7. 25 plus 8 is 33. This will give a remainder as a 6 when we will divide it by 9. 9 3 27. 33 plus 8 is 41. Now this will give remainder as a 5 when divided by 9, and these are giving remainder as a 1 when divided by 8. So we have to check both the conditions with which we are dividing. The number should satisfy both the conditions. Clear, students? Now we will move to question given on slide. Again same, divided by 72. What is the answer? Again I have already done. It is another example. We know what is check of 3. What is check of student 8? 8 into 9. This 8 and 9, these should be co-prime. 8 into 9, 72. Check of 8 is last 3 digit. 9, 4, 3 divided by 8. Remainder will be 8 ones the 8, 8 ones the 8, 8 7, 56. Remainder will be 7. When we will divide this number by 8, remainder should be 7. And what is check of 9, student? Sum of digits should be divisible by 9. 3 plus 4 is 7, 7 14, 2 16, 8 24 plus 9 is 33, plus 4 is 37, 3 40. When 40 divided by 9, you will get remainder as a 4. Now the question is reduced to, we have to find a number, students. We have to find a number when divided by 9, when divided by, students, 9 gives remainder 4, and when divided by 8 gives remainder 7. We have to find the least number. So again you can write, by writing 9, remainder is 4, as we have already done. 4 plus 9 is 13. 4 plus 9 is, student, 13. 13 divided by 9, remainder is 4, but 13 divided by 8, remainder is 5, and we want by 8 remainder should be 7. 13 plus 9 is 22. 22 divided by 8 gives remainder 8 to 16, 6. Not possible. 22 plus 9 is, we have to add 9. 22 plus 9 is 31. This 31 is the number which are satisfying these both conditions. When divided by 9 gives remainder 4, and when divided by 8 gives remainder 7. So answer for this question is 31. 31 is the answer, students. Again, have a very good theorem, because right now we are writing, but after practice, believe me, you can do these questions within seconds, because if 4 choices are given, and if in the choices, now again I will tell you this with the help of example in a later stages. Now next question, find the remainder when 917394285 is divisible by 144. Again break this number into two parts, which should be co-prime. 9 into 16. 9 into 16 is 144, and 9 and 16 are co-prime. Both the numbers are natural composite number, but again if you will say 9 and 16, HCF should be 1. Common factor is 1. And what is check of 9? We have already done. You will do addition. 9 plus 1 is 10, 7 17, 3 20, 29, 33, 35, 43 and 48. 48 when divided by 9, remainder will be 3. 48 when divided by 9, remainder will be 3. And what is the check of 16, students? Check of 16. Last 4 digits should be divisible by 16. Last 4 digits should be divisible by 16. Now check last 4 digit. What is the last 4 digit? 4285. 4285 when divided by 16, what is the remainder? 16 to 32, remainder is 10, 16, 6, 96, remainder will be 12, 16, 7, 112, remainder will be 13. So now quotient is converted when divided by 9, remainder is 3, and when divided by 16, remainder is 13. Now we have to check the condition, we have to check the numbers where these both the least number, where these both the conditions are satisfied, students. Now again make cycle, you write big number, when divided by 16, remainder is 13. Now what you will do? Add this 16 to the 13. 13 plus 16 is 29. 29 when divided by 9 gives remainder 9, 3, 27, 2. 29 plus 16 is 45. Now remainder is 0. 45 plus 16 is student 55 and 61. Now remainder is 7. 61 plus 16 is 77. Now remainder is 5. 77 plus 16 is what we want. We want remainder should be 3 divisible by 9. 77 plus 16 is 93. 93 is the number, students, where these both the conditions are satisfied. These both conditions, because 93 gives remainder of 3 when divided by 9 and remainder of 13 when divided by 16. Again, now if in the exam, suppose students, now we are making here a cycle, but believe me, in the exam you are not supposed to make cycle. Suppose in the paper, if it is given, just understood it, students, in a paper suppose 4 choices are given, like first choice 121, second choice 130, third choice 93, and fourth choice 83. Now then there is no need to solve this question. Simply what you can say, divide by 9, what is the remainder? 3. Simply you will check 121 when divided by 9, what is giving remainder? 121 divided by 9, it is giving remainder as a 4, rejected. 130 divided by 9, giving remainder as a 4, rejected. Because when these numbers are not satisfying condition with 9, why to check the other numbers? Then 83 divided by 9, remainder will be 2, and we are left with a number only 93, which is giving remainder as a 3 when divided by 9. So there is no need to check by 16. But again, suppose if fifth option is given, when divided by 9, remainder is like 30, suppose remainder is 30. Now these two numbers are giving same remainder, students, divided by 9, remainder is 3 in both the cases. Now here we have to check the remainder by 16 also. When we will divide it by 16, remainder should be 13. So this is not giving remainder as a 13. So answer will be 93. There is no need to make cycles, students. There is no need to make cycles. Simply you can do by choices. Because in lengthy question, in the typical question remainders, this theorem can be, believe me, very, very, very useful to you. So we have done a lot of examples on Chinese remainder theorem where we can use. And now use this concept of Chinese remainder theorem on another question. And now students, just do the application portion of Chinese remainder theorem in a question based on remainder. Find the remainder when 1, 2, 3, 4, 5, 6 till number is written up to 34. Looking very difficult question when divided by 40. But again, what we have to do, students, we have to convert this number into co-prime factors. What is co-prime factor of 40? Two factors which will be co-prime, students. Is it 4 and 10? 4 and 10? No, students, because 4 and 10 HCF is 2. What should be HCF? 1. So for 40, co-prime factors are 5 into 8. 5 into, students, 8. And what is check of 5, students? What is check of 5? Divisible check of 5. Last digit we have to check. Last digit. In last it is given 4. Yeah, or you can say 34 divided by 5. Remainder will be 4. Remainder will be 4. Simply you can check last number. If it is given 2, remainder will be 2. If it is given 1, remainder will be 1. Clear? Then what is check of 3? Last 3. What is check of 3, students? Oh, sorry. What is the check of 8? Last 3 digits. Last 3 digits should be divisible by 8. 334 when divided by 8. What is the remainder? 8 4 32. 8 1 8. Remainder will be 6. Remainder will be 6. Now what we have to find? Again same concept. We have to find the least number. We have to find the least number which when divided by 8 gives remainder as a 6, and when divided by 5 gives our remainder 4. Now if choices is given, simply you can go through the choices. Which choice is given remainder as a 4 when divided by 5 and as a remainder 6 when divided by 8, students. Now you can make cycle here for our practice. What is the cycle? We can write 8 6. What is 6 plus 8? 6 plus 8 is 14. 6 plus 8 is 14. Now check 14 when divided by 5 gives remainder 4. Yes. 14 is the number when divided by 5 is giving remainder as a 4. So answer will be 14 because 14 is the least number which when divided by 8 are giving remainder 6 and when divided by 5 are giving remainder as 4. So what is the answer? Answer is 14 is the remainder when you will divide this big number 1, 2, 3, 4, 5, 6, 7, 8 till 33, 34 by 40. Again we have done the application, students. Now move to next question. Again now in this question choices are given, students. But here again you should know the one question of cyclicity of remainders. I will try to explain you in a brief, but for this we can do this concept on another slide when we are doing the application of cyclicity with Euler number. But again here I will like to tell you what is the meaning of cyclicity. Again, students, if I ask you simple for this, I will come to this question on a later on stages. First of all, I would like to tell you what is the meaning of cyclicity. What is the meaning of cyclicity? Simply if I say 5 raised to power 12 divided by 8, what is the remainder? What is the remainder? It means 5. It means, students, 5 into 5 into 5 into 5 into 5 is written how many times? 12 times. 12 times. When divided by 8, what is the remainder? Initially, what we will do, when I will divide 5 by 8, I am writing here 5 divided by 8, remainder will be 5. Remainder will be 5, students. 5 divided by 8, remainder will be 5. After that, again we will take two numbers. That means 5 square. 25 divided by 8, here remainder will be 1. Then after that what we have to do? 5 into 5. Can I say 5 square? 5 square is 25 divided by 8, remainder will be 1. Now can we say, after that again, I will take third 5. 5 divided by 8, remainder will be again 5. Again I will take 5 into 5, 25, remainder will be 1. Can we say the cycle of this number is of 2? After every second number, we are getting remainder as a 1. So when and how many numbers are given? 12. When we will divide 12 by cycle is of 2, remainder will be 0, and when the remainder is 0, you will go to the last number. That means answer will be student 1. Again, if instead of here 5 raised to power 11 divided by 8, then what should be the answer? Again cycle is 5 divided by 8, remainder is 5. Then you will do 5 square divided by 8, 25 by 8, remainder will be 1. Cycle is of 2, 11 divided by 2. Here 6 cycles are there complete. Here 5 cycles are there and 1 is the remainder. So in the first number, what is the remainder? It is given 5. So for this, answer is 5. Now I'll take another example, students, where cycle is of more length. If I'll say 3 raised to power 13 divided by 5, what should be the remainder? What is the meaning of cycles, students? Again, first of all, what you will do? 3 divided by 5, remainder will be 3. After that, second step is, what is second step? This is first step. This is first step. Second step is 3 into 3. 3 into 3, 9 by 5. What is the remainder? 9 by 5 remainder is 4. This is second step. Now what is third step, student? You will multiply 3 into 3 into 3, or can we say 4 into 3? Either you can do 3 into 3 into 3, 27 by 5. Remainder will be like which already we have done in the initial remainders theorem. 27 by 5, remainder will be 2. Again, why 2? Because 3 into 3 is 9. 9 divided by 5, remainder will be 4. Can we say 4 into 3? Like 4 into 3, 12 divided by 5, remainder will be 2. This is third step. This is third step. And then again, this 2 into first number 3. 2 into 3, which will be 6 divided by 5, remainder will be 1. This is fourth step. And when you will get 1, student, then you have to stop there. Then we have to stop there. This is the meaning of cyclicity. That means 3 raised to power 13 when divided by 5 give a cycle of 4. After every fourth number, there will be a remainder of 1. So in 13, how many cycles are there? Of 4. Complete 3 cycles are there, and remainder will be 1. So in the first place, what is the number? Number is 3. So answer will be 3 in this case. Is it clear, students? Cyclicity. Why? We will do it in a detail in a next lecture. In a lecture on, you can say, cyclicity and Euler number, in which we can do it in a detail. And right now, because we are doing application portion, so in this question, how you can use this theorem? Convert this 360, students, into into numbers, into factors which are co-prime. Like 8 into 9 is 72, into 5 is 360. Clear? Now if now question convert into 13 raised to power 101, if divide by 5, like which we have already done, what is the remainder? We can see 13 divided by 5, remainder will be 5 to 10, 3. After that, what we'll do? 3 into 3 is 9, divided by 5, remainder is 4. After that, what we'll do? 4 into 3 is 12, divided by 5, remainder will be, student, 2. Again multiply first number. 2 into 3 is 6, divided by 5, remainder will be 1. So that means cyclicity is of 4, students. Cyclicity is of 4. Now 101, this 101 power divided by 4, 25 whole cycles will be there, which we have nothing to do. And what is the remainder? Remainder is 1. 1 is the remainder. So in the first place, we have to see what is the number in the first place? 3. So that means 13 raised to power 101 when divided by 5 gives remainder as a 3, which give remainder as a 3. So now just check, which I am not going through 8 and 9. Simply after dividing by 5, I will see the choices. 111 divided by 5 remainder is 1, not possible, because what I want is remainder should be 3. 122 divided by 5 remainder is not 3, remainder is 2. 126 divided by 5 remainder is 1, and 133 divided by 5. Only this option is giving remainder as a 3. Then why to waste time on 8 and 9? Simply you can mark as a option 4 when divided by 13 is 101 divided by 360. Remainder is 133. Again at your own place, what you can do, you can check it by 8 and 9, because 133 when divided by 8 will give remainder 8, 16, 1, 5, and when divided by 9 it will give remainder as a 7. You can just check. Okay, students, it is the application of the Chinese remainder theorem on a questions with the help of choices. Convert the number into co-prime factors, convert the number into co-prime, 8 into 9 into 5. After that, what I have done, I have checked the divisibility by the cyclicity. 13 is to the power 101 divided by 5. 13 by 5 remainder is 3. Again, I have told you 3 into 3, 9 divided by 5 remainder is 4. And if you want to do this concept in a detail, then we will do it in a another video, detailed video on cyclicity and Euler number. Okay, now let's move to another. Now it is a set of practice questions which you have to do at your own place. 3, 7, 2, 8, 4, 3, 7 divided by 36. What should be the remainder? Find the remainder when 1, 2, 3, 4, 5, 6, 70 to 74 divided by 20. And again, find the remainder when 11 is to 16 divided by 48. Again, you can go through choices also, students. Like you can convert the number into co-prime, 48, 3 into 16, and then you can check the answers. And last is by negative remainder. Clear, students? And then their answers are, these are their answers which you can check at your own place. Okay, students, I think that all of you have understood the concept of negative remainders and Chinese remainder theorem. So okay, students, thank you very much.